Welcome to another deep dive. Today we're going to be talking about something that's pretty essential if you're interested in the world of massive online applications.
Yeah, we're talking about ZooKeeper.
ZooKeeper. Now, this is one of those things that, powers all these apps that we use every day. You know, those apps that just kind of seem to work like magic, even though they're spread across tons of computers.
Exactly. And ZooKeeper is really one of those key pieces that makes that magic happen.
We're really lucky to have a great research paper to help guide this deep dive today.
Yeah, it's called ZooKeeper, Weight-Free Coordination for Internet Scale Systems.
And it's by Hunt, Konar, Junqueira, and Reed.
Yeah, so it sounds a little intimidating at first, but I promise you the concepts are actually pretty fascinating once you break them down.
Okay, so let's start with the basics. What is ZooKeeper? I mean, I know it's not about like taking care of animals at the zoo,
Right.
but I'm still a little fuzzy on what it actually does.
Well, think about it like this. Imagine a really busy airport, with planes landing and taking off constantly. You need air traffic control to make sure that everything runs smoothly.
Right.
ZooKeeper is kind of like air traffic control, but for large-scale distributed applications.
So it's about managing all the different parts of an application that are spread out across multiple computers.
Exactly. And it helps those different parts communicate with each other, share information and stay in sync, which is crucial for things like keeping your data consistent and making sure that different parts of the application are working together, even handling situations where, like, some computers might fail.
Got it. The paper mentions this hierarchy of nodes. Can you elaborate on that?
Yeah, so ZooKeeper basically organizes information in a way that's similar to the folders and files on your computer. And these nodes are like containers that can hold data.
Yeah.
Or even others' nodes.
Okay.
And this creates like a tree-like structure that makes it easy to manage and access information.
Okay, so it's like a family tree, but for data.
Yeah, I think that's a good way to think about it. And this structure is really key because it allows different parts of an application to have specific places to store and retrieve information, kind of like their own little cubby holes in a way.
Now, I've heard this term weight-free being thrown around.
Yeah.
What makes this concept so important for ZooKeeper?
Well, it's all about speed and resilience. So in a large-scale distributed system, you can't afford to have every single component waiting on the slowest one.
Right.
Weight-free means that if one part of the system is slow or even crashes, it won't bring the entire system to a halt.
Okay, that sounds incredibly useful. Can you give us like a specific example of how this weight-free design might play out in a real-world scenario?
Sure. So imagine you're using a social media app.
Yeah.
And that app relies on ZooKeeper for coordinating its services.
Okay.
Let's say that one of the servers that's responsible for handling user profile updates, let's say it's experiencing some issues. In a weight-free system, other parts of the application, like the newsfeed or the messaging features, those can continue to function normally.
So even if one part of the app is having a bad day, my experience as a user isn't necessarily impacted.
Exactly. And that's really a huge win when you're dealing with systems that need to be available and responsive 24/7.
Now, the paper also mentions these concepts: FIFO client order and linearizable writes. I'm not going to lie, those sound pretty technical.
Yeah, they do.
Do you break them down for us?
Of course. So FIFO client order, that's all about ensuring fairness. It basically guarantees that requests from a single client are processed in the order that they were sent.
Okay.
This prevents situations where one client's requests keep getting pushed back, while others get to jump ahead in line.
So it's like a first-come, first-served system for the request.
Precisely.
Okay.
Now, linearizable writes, that ensures that all updates to the ZooKeeper system, they happen in a specific agreed-upon order. Now, this might sound kind of simple, but in a distributed system where multiple computers are trying to make changes at the same time, it's really crucial for preventing conflicts and maintaining data consistency.
So it sounds like these concepts work together to ensure that everything stays organized and predictable, even in kind of a chaotic environment.
Exactly. And that predictability is really essential for building reliable distributed applications.
Now, another term that pops up a lot in the paper is watches.
Right.
What are these watches? And why are they so important?
Okay. Well, imagine that you're waiting for a really important email.
Yeah.
You could keep refreshing your inbox every few seconds, but that's not very efficient, is it?
No.
Watches in ZooKeepers are kind of like notifications that tell clients when something they're interested in has changed, without them having to constantly check.
Okay, so instead of wasting resources constantly checking for updates, clients can just subscribe to notifications. And react when something relevant happens.
Exactly, and it's a much more efficient way to keep track of changes and react accordingly.
So I'm starting to see how these different pieces, all these different concepts kind of fit together to create this system that's both really efficient and really reliable.
Yeah, it's really like a well-choreographed dance, where all the dancers know their steps and they move in perfect harmony.
Now, the paper mentions that ZooKeeper is actually used for a variety of different purposes, like configuration management.
Hmm.
Can you give us like a concrete example of how that works in practice?
Sure. So imagine you have a website that's hosted on multiple servers, to handle a lot of traffic. You might use ZooKeeper to store the configuration details for those servers, things like the location of files, database connection settings, or security policies.
So if one server goes down, ZooKeeper can help the other servers pick up the slack
Right.
and keep the website running smoothly.
That's definitely one of the benefits. ZooKeeper can help ensure that all the servers have access to the latest configuration information, even if there are changes or failures.
That's incredibly useful.
Mm.
Are there any other common scenarios where ZooKeeper's configuration management capabilities might come in handy?
Oh, yeah, there are tons. It's used in a wide range of applications, from managing load balancers to coordinating database updates and even deploying software updates across a whole cluster of servers. Basically, anywhere where you need to manage shared configuration information in a distributed system.
Okay.
ZooKeeper can be a really valuable asset.
Now, the paper also mentioned something called rendezvous. What does that mean in the context of ZooKeeper?
Okay, so imagine you're trying to meet a friend in a really crowded park, but you haven't decided on a specific location beforehand.
Okay.
ZooKeeper can act as that central meeting point, where different parts of a distributed application can find each other and exchange information, even if they don't know each other's details in advance.
So it's like a digital bulletin board where
Mhm.
components can leave messages for each other.
That's a good analogy. And this capability is really useful for situations where you have these dynamic systems where new components might join or leave at any time.
Okay. This is starting to paint a much clearer picture for me of how ZooKeeper is actually used in practice. It sounds like it plays a really crucial role in keeping these really complex distributed applications organized and functional.
Yeah, it's definitely a fundamental building block for many large-scale distributed systems.
Now, the paper goes on to discuss how companies like Yahoo have actually used ZooKeeper to manage massive amounts of data.
Hmm.
I'm really curious to kind of dive into those real-world examples and see how all this comes together in practice.
Yeah, me too. Let's explore how Yahoo used ZooKeeper to handle the complexities of indexing billions of web documents and, managing their massive message broker system.
Okay, lead the way. This is where it gets really interesting.
Yeah.
I'm eager to see how these theoretical concepts that we've been talking about actually translate into tangible results.
Absolutely.
Okay, so let's jump into those real-world examples.
Yeah.
You were talking about Yahoo.
Yeah, so Yahoo, they use ZooKeeper for some pretty impressive things.
Yeah.
One example is their fetching service,
Okay.
which is a part of their web crawler that, indexes billions of web documents for their search engine.
So when Yahoo was gathering all that information to build their search results,
Yeah.
ZooKeeper was like helping to manage that whole process.
Exactly. The paper talks about how they used it to assign tasks to different crawler processes, manage the configuration, and just make sure everything's running smoothly.
Okay.
It was kind of like the conductor of an orchestra,
Okay.
making sure that all the instruments are playing in sync.
Given the sheer scale of the web, I mean, that must have been a pretty demanding job for ZooKeeper.
Yeah, it was.
Did the paper mention any specific challenges that they faced in using it for that purpose?
It did. One challenge was handling server failures. You know, imagine one of the computers that's running the crawler crashes. ZooKeeper has to detect that failure really quickly
Yeah.
and reassign those tasks to other servers and keep the whole operation going.
Wow. So it's not just about, coordinating the task, but it's also about making the system resilient
Right.
and able to adapt to those unexpected problems.
Exactly. And the paper really highlights how ZooKeeper's design, particularly the wait-free concept we talked about earlier,
Yeah.
was really crucial for keeping that crawler running smoothly, even when things went wrong.
That makes a lot of sense because you don't want one single server failure to bring down the entire, web crawling operation.
Right.
What other interesting things did the paper reveal about Yahoo's use of ZooKeeper?
Well, figure 2 in the paper actually shows just how much activity ZooKeeper was handling.
Right.
And over a 3-day period, a single ZooKeeper server processed thousands of operations every second.
Thousands per second. That's mind-boggling. Was there anything interesting about the types of operations it was performing?
Yeah, absolutely. The vast majority of those operations were reads, which makes sense for a web crawler because it spends most of its time fetching and reading data with relatively few updates.
Right. And if I remember correctly, reads are actually much faster in ZooKeeper
Yes,
because they can be handled locally on each server.
that's right. And that's one of the reasons why ZooKeeper is so well suited for those read-heavy workloads like web crawling,
Okay.
because it can handle this huge volume of requests, without getting bogged down.
So ZooKeeper helped Yahoo conquer the challenge of web crawling.
Yeah.
What other real-world applications did the paper mention?
They also used it for their message broker,
Okay.
which is a system that handles millions of messages every day.
Message broker. Can you paint a picture of what that system kind of looks like and what it does?
Sure, imagine like a giant post office
Okay.
where people can send letters to specific mailboxes,
Okay.
and then other people can subscribe to those mailboxes to receive the letters.
Okay.
That's essentially what a message broker does, but for digital messages.
So it's like a central hub for distributing information between different parts of a distributed system.
Exactly. And in Yahoo's case, they were using it to handle the communication between all sorts of different services like email, instant messaging, even things like stock quotes.
Wow. So that sounds like a pretty critical piece of infrastructure.
It is.
How did ZooKeeper help manage a system that complex?
Well, played a few key roles.
Okay.
For example, it managed the distribution of topics across the different servers.
Okay.
So it was ensuring that messages were routed to the correct destinations.
Okay.
It also helped detect and handle server failures
Right.
so that the message broker could keep running even if some servers went down.
So it was kind of responsible for keeping the mail flowing, even if some of the post offices were closed?
Yeah, that's a great way to put it. And the paper also mentions that ZooKeeper provided like the centralized control,
Okay.
allowing administrators to kind of monitor and manage the entire message broker system.
So it sounds like ZooKeeper was really essential for ensuring the reliability and scalability of Yahoo's message broker.
It was. And, these are just two examples from the paper.
Right.
ZooKeeper is used in a wide range of applications, from managing distributed databases to coordinating the work of cloud computing platforms.
It's really amazing to see how this seemingly simple concept
Right.
of like a hierarchical structure with weight-free operations
Yeah.
can be used to solve such complex problems.
It really is. It's a testament to the power of, elegant design and computer science.
Yeah.
By focusing on just a few core principles, ZooKeeper provides this foundation for building these incredibly robust and scalable systems.
Now, the paper also gets into some of the internal mechanisms of ZooKeeper,
Yeah.
like how those client-server interactions actually work.
Right.
Could you shed some light on some of those details?
Absolutely. Let's take a closer look at how clients connect to the ZooKeeper system, how they manage those watches that we talked about,
Yeah.
and how ZooKeeper handles client failures. So we talked about how Yahoo used ZooKeeper for those big tasks,
Right.
but, everything has trade-offs.
Right. Are there any like limitations or challenges of using ZooKeeper? Is it really the perfect solution for every distributed system?
Well, like any tool, it has its trade-offs.
Yeah.
One thing to think about is that it's a centralized system,
Okay.
which means that it relies on a leader server to coordinate updates.
Okay. So if that leader server goes down, doesn't that mean the whole system kind of grinds to a halt?
Not necessarily. ZooKeeper is actually designed to handle leader failures pretty gracefully.
Okay.
It has a built-in mechanism for quickly electing a new leader,
Okay.
and the system can actually keep operating during that election process.
So it's not a single point of failure in the sense that the whole system crashes if the leader disappears.
Right.
But couldn't this leader election process still cause some delays or disruptions?
It's true that there is, a brief period of adjustment while that new leader is chosen. And in systems that require extremely low latency, that could be a concern.
Yeah.
But in most cases, the impact is pretty minimal.
Got it. Are there any other potential drawbacks or things to watch out for when using ZooKeeper?
Well, one thing to keep in mind is that ZooKeeper is really designed to store metadata,
Okay.
not large amounts of data.
Okay.
So think of it more as a place to keep like configuration details, status updates,
Right.
or coordination information,
Okay.
not your entire database.
So it's more about managing the signals than like the actual freight of the system.
That's a good analogy. And if you try to store too much data in ZooKeeper, it can actually impact the performance.
Okay.
So it's important to use it for its intended purpose,
Right.
which is really that coordination and management, not bulk data storage.
So choose the right tool for the job.
Exactly.
Anything else to keep in mind?
Well, ZooKeeper does require some careful configuration and management.
Okay.
It's not really a set it and forget it kind of system.
Mm.
You need to make sure that the servers are properly configured,
Yeah.
monitored, and maintained to make sure everything's running smoothly.
So you need someone who knows what they're doing to set it up and keep an eye on things.
Yeah, exactly. And while ZooKeeper is really designed to be robust and, handle failures gracefully,
Right.
you still need to plan for those failures
Of course.
and have appropriate monitoring and recovery mechanisms in place.
It makes sense you wouldn't build a skyscraper without considering how to handle earthquakes or strong winds.
That's right. And just like a skyscraper needs, regular inspections and maintenance, a ZooKeeper system also needs that ongoing attention to ensure its reliability and performance.
So we've talked a lot about how ZooKeeper's used today.
Right.
Where do you see ZooKeeper going in the years to come? Is this a technology that's going to stick around? Or could it become obsolete as new approaches emerge?
Well, considering how fundamental ZooKeeper has become for, so many large-scale distributed systems, I think it's safe to say that it's here to stay for at least the foreseeable future. But it's also a technology that's constantly evolving.
So what sorts of advancements or changes do you anticipate seeing?
Well, one area where I see continued development is in performance and scalability.
Okay.
So researchers are exploring new ways to make ZooKeeper even faster and more efficient, especially as the demands of distributed systems, continue to grow.
So making it able to handle even more requests and larger systems without breaking a sweat.
Exactly. Another area of focus is security.
Okay.
As distributed systems become more and more critical to businesses and infrastructure,
Yeah.
ensuring the security of coordination mechanisms like ZooKeeper is super important.
Yeah.
So we'll likely see more advancements in areas like access control, encryption, and threat detection.
Makes sense. You don't want a bad actor messing with the air traffic control system.
Right, exactly.
Yeah.
And finally, I think we'll see, more integration of ZooKeeper with other technologies, particularly in the cloud computing space. As more and more applications are deployed in these cloud environments, ZooKeeper will likely play an even bigger role in managing and coordinating those distributed systems.
So it's not just a standalone tool,
Yeah,
but something that will increasingly become part of a larger ecosystem.
exactly. And that will, open up all sorts of new possibilities and make it easier for developers to build and deploy these really sophisticated distributed applications.
Well, this has been a really enlightening deep dive.
Yeah.
We've covered, the basics of ZooKeepers, explored its real-world applications at companies like Yahoo,
Right.
and it even glimpsed into its potential future.
Yeah.
I feel like I've gained a much better understanding of this really crucial technology.
I'm glad to hear it. It's always fascinating to explore these foundational technologies that make so much of the digital world possible.
Absolutely. And a huge thank you to our listener for suggesting this topic
Yeah.
and providing that research paper.
It's been great.
It's been a pleasure kind of exploring this with you.
The pleasure was all mine.
And to all our listeners, thank you for joining us on this deep dive.
Yeah. Thanks for listening.
We hope you've enjoyed the journey and learned something new along the way. Until next time, keep exploring, keep learning, and keep diving deep.